This is day 7 of Focus and Directrix. We're still in Unit 1, Quadratic Functions and Expressions, and this is our last day in this unit. What we're talking about today is the focus and directrix of a parabola. As you can read up here, a parabola is the set of all points in a plane that are the same distance from a point called the focus and a line called the directrix. So if you have a parabola, the focus is always inside the parabola, and the directrix is always a line outside of it. And here's the thing about it. If you were to connect a random point somewhere on the parabola to the focus, that would be the exact same distance it is from the directrix. Those two distances would be the same. I didn't really draw this to scale, so please forgive me that. And that's true for any point on the parabola. The distance from that point to the focus is the same as it is from the directrix. No matter where you go on the parabola, that is true. Even the vertex is smack dab in between the two. Same distance away. Now, how do you know what the focus and directrix is? Well, you use this nifty formula that you should copy into your notes. If you're in vertex form, h comma k, you can see that the focus is found by doing h comma k plus 1 over 4a. Simple formula. The directrix, y equals k minus 1 over 4a. There you have it. We do not need to worry about the length of the latus rectum. That's actually the line segment that's horizontal going through the focus. That right there, that would be your latus rectum going from this end point to this end point. But not something in our class, and I've actually never heard about it until teaching this class, and our textbook used it. So in example 1, we're going to determine the focus and directrix of this function. I know, I'm just making a quick rough sketch here, that the vertex would be at positive 3, negative 4. Because if this is in vertex form. I know that this thing would be opening up and it would have been stretched vertically. Now what I'm after is, what's the focus? Somewhere maybe in here. What's the directrix? This line right here. And we'll see what that is. We're going to use the formula. So to do that, the focus. For the focus, I already know the x value. For the focus, the x value will always be the same as the x value was for the vertex, so the x value is 3. The focus will always lie on the axis of symmetry. Now, as far as your y value, that's where you're going to use the formula, and it said k plus 1 over 4a. And I'm just going to apply that now, that the value of a in this case was 2. So, and the value of k, was negative 4. So negative 4 plus 1 over 4 times the value of a is 2. And so that's negative 4 plus 1/8. And if I add 1/8 to negative 4, I get negative 3 7/8. So it's actually really, really close to the vertex. It was pretty much right there at it, is where it accurately was. I'm going to go ahead and write that in right now. You could have also listed it as an improper fraction if you prefer. Now for the directrix. The directrix is always going to be a line for a parabola, and for what we're studying right now, they're always going to be horizontal. So it's going to be y equals some number. Now what you use for that is you do the exact opposite. Instead of k plus 1 over 4a, you're going to use k minus 1 over 4a. And that would be, in this case, negative 4, our k value, minus 1 over 4 times 2. And simplify that, and you get negative 4 1/8, just below the vertex. So where I had drawn it before is not exactly the most accurate thing in the world. It's really, really close to that vertex. So there's my directrix. Y equals negative 4 1/8. And there's my two answers. So on example 2, it's in standard form. I'm going to use my calculator to calculate my vertex really quick. So if I go to y equals and I just type it in, -1/8 x squared minus 12x plus 6. What I'm going to do is I'm just going to go ahead and jump to the graph and take a look at it here. And I can hopefully see it. I can see where it went down, and it doesn't look like it's really coming back up on the screen. So what I'm going to do is I'm going to zoom out. So click the zoom key, go to out, and we will zoom out and take a closer look at this. And there it comes, and never really saw it. That's really because the A factor is so minuscule. Let's do something called zoom fit. It's the 0 option, the 10th option down if you hit zoom fit. It's a really handy one, and it'll let you see things sometimes. Now I'm actually starting to see the arc of this thing. This might actually be a whole lot more work than just doing negative b over 2a, but whatever, we're in it now, so let's go for it. So the vertex is over here further to the left, so what I'll do is I'll just stretch the window by hitting window, and I'll give it an x minimum of maybe like -100, where it was -40. I'm totally guessing there, but whenever I go back to my graph now, I can actually see where that vertex is, that it's right up here on the very top edge of the screen. And I'm going to calculate that now by doing, first of all, this is a maximum. You need to make sure you realize that. So it has a maximum on this one. So second, calculate the trace key. Alright, and you're going to want to select maximum. Once you hit enter on that, you're wanting to give it a left bound. The cursor is not to the left of the vertex. The vertex was right here, so you need to go into the left of that vertex. And I'm going to stop right there and hit enter. You can see the left bound that it's been given now. Now I'm going to go to the right of that vertex. Stop and hit enter for a right bound. Hit enter for the calculator to guess. And it says the vertex is 48,294. And that's what we'll work with. So, y equals -1/8 times x plus 48 squared plus 294. What I did was I just kicked that into vertex form, because now I know what h and k and a are. Because once you find your vertex, you can go ahead and get it there. Now what we're going to do is actually see what's going on with this function. What I'm going to do is the same process as we did just a moment ago for focus and directrix. For my focus, I'm going to have a x value of -48. I know that because that was the x value of my vertex. To know my k value, that's where I have to do k plus 1/4a from the very first notes that we took. So now I'm going to apply that here. The k value was 294. So 294 plus 1/4 times -1/8. That looks absolutely awful, but it's not too bad, and here's why. 1/4 times -1/8. Well, that's 294 plus 1/1/2. 4 times -1/8 is -1/2. And if I do 1 divided by -1/2, well, remember, you can multiply by the reciprocal, so that's -2. So I have 294 plus -2, so my y value is 292. It's actually below the parabola over here. There's my focus. Now moving on to my directrix. It's going to be y equals, now what do? You do 1 minus 4/a. Now, or excuse me, k minus 4. Lord, I messed that all up, excuse me. Apologies. It's going to be k minus 1/4a. From, again, the notes that we took at the beginning of class. So, let's go ahead and insert our stuff here. The k value is 294 minus, and I actually already know what 1/4a comes out to. It comes out to -2. So I'm just going to put -2. 294 minus negative 2. Well, that's 294 plus 2, and that's 296. There's my directrix. And I'm done with this problem. Now we're going to go the opposite direction on number 3, where they'll give you information. Maybe it's a vertex and directrix, maybe it's a focus and directrix, maybe even a focus and a vertex, and you're expected to come up with the equation of the line. To do that, I actually already know what H and K are on this problem because they're giving me the vertex, so that's actually really nice. I know my final answer is going to look something like y equals some number for A. I'll write that in, but I'll be erasing it here in a moment, times x plus 2 squared minus 4. Because of what my h and k values were here, I already know almost my entire answer. I need the value of a, though. To do that, you're going to refer, in this case, to the directrix. And if you'll recall that to find the directrix, it is k minus 1 over 4a. In this case, I know that the answer to that comes out to 1. And I also know the value of k is negative 4. So I'm going to say that 1 equals negative 4 for k minus 1 over 4a. And now I'm going to solve that for a. Not too difficult, just going to add 4 to both sides. So I get 5 equals negative 1 over 4a. Personal preference, I prefer to just multiply by a on both sides. That way it gets it to cancel out on the right hand side, and I have 5a equals negative 1/4. And now I'll be able to divide by 5. So a would equal negative 1/20. Now I can actually go back to where I'm putting my answer and write in negative 1/20 for my answer there. Final answer being y equals negative 1/20 times x plus 2 squared minus 4. Now on example 4, they're giving me different information here. They're giving me the focus and the directrix. On the upside, it's pretty easy to tell what your vertex is going to be from that given information. So if the focus is at the coordinate 1, 3, and my directrix is the line y equals 4, I actually know that my vertex needs to be spot on between them. So my vertex is going to be 1, 3.5. And now I'm actually ready to solve my problem. So got my h and my k, the 1 and the 3.5. So my answer is going to be looking something like y equals a times x minus 1 squared plus 3.5. You could also use fractions there, that's totally fine. I'm going to now figure out what a is. I could use either my focus or my directrix to do that. If I use the 4 here from my directrix, I would set that equal to k minus 1 over 4a. If I use my focus, I'm going to take the y value of 3 and set that equal to k plus 1 over 4a. And that's actually what I'm going to do. You'll get the same answer for a either way, and I'm going to go ahead and replace that k with a 3.5, and I'm going to subtract that 3.5 from both sides. So I have negative 0.5, or negative 1/2. It'll be easier to work with a fraction for me since I'm doing this by hand, equals 1 over 4a. And now what I'll do is I'll actually do the thing where I multiply by a again. So I'll have negative 1/2a equals 1/4. And what I'll do is I'll multiply by the reciprocal here, which is negative 2 on both sides. And I'll have that a is equal to 1/4 of negative 2, which is negative 1/2. So a is equal to negative 1/2. And there's my answer. Y equals negative 1/2 times x minus 1 squared plus 3.5. And we're done with focus and directrix. Not a huge component of this course, but it is something that you are expected to know.